Hello, and welcome back to Uncle Sal's Garage. On the last episode, we sealed up the bottom end. We got the crank in there, the cam, we got our oil system all set up, and we sealed the two case halves together. On today's episode, we're going to measure the piston height relative to the cylinder so that we can calculate our compression ratio. We're going to install a crank position sensor for a fuel injection one day. We're going to seat the pistons by gapping and clocking them. And finally, we're going to measure our combustion chamber CCs. Step 1, installing the crank position sensor. You know, for fuel injection one day.
Okay, let me talk you through what I'm doing here, because this is definitely not part of the normal engine rebuild process. So one day this car will be fuel injected. That day is not today. But so I don't have to pull it out, the engine out, and fit this particular sensor. I'm kind of doing it now, and hopefully I will take advantage of it later on down the road, which is this crank position sensor offered by the Dub Shop. And it's a really cool piece of kit that sort of you put this plate onto the fan hub, the kind of the crank here. What's going to happen is it's going to know where the crank position is because one of these teeth are missing. And so every time the tooth goes in front of this magnet, I guess, it'll read 0 on your voltmeter. And then every time there's a gap, it'll read 5.8 or whatever, how many volts. And it'll do that pretty consistently. And then there'll be one area that it lasts for longer. And so that's used to mark where the crank is, the position of the crank. So I just got done installing the sensor itself onto the case, and I snugged this down, and I put this on, and I rotated the engine a little bit, and I got the correct volt readings. So I'm going to call this part done, and I'm going to snug down the case bolts one last time, make sure they're right to torque, and we'll be on to the next step.
Step 2, measuring the combustion chamber CCs. Okay, measuring the combustion chamber volume. What I've done is I've got a clear plastic disc here that I put 2 holes in, and we're going to put it on top of here, and we're going to start filling it up with fluid and see what happens. Now, honestly, I can't tell. There's air bubbles and it's leaking, so I have no idea. Where we are volume-wise. But after cleaning up the disc and letting the liquid settle, we did know where we are. I think it's 60 millimeters, 60 cc's, 60 milliliters. A little bit of water leaked out on the side, and there's 2 tiny air bubbles, but the rest of it is definitely full. $60 milliliter chamber. And just to confirm, since I'm new at all this, I did call the makers of these heads, and they confirmed that they were 60 milliliter chambers, so we have our measurement. Step 3, measuring the deck height. Okay, so I had to jerry-rig a contraption here to just hold the cylinder in place while I tested the deck height here. And this is cylinder number 1 at top dead center, and as you can see, it sits pretty proud above the surface. So we're certainly going to have to add some shims to get the right deck height to get the right compression. Okay, this is pretty difficult to do one-handed, so I'm going to pause the video as I perform each step. The first thing I'm going to do is I'm going to place a straight edge across the cylinder, and I'm going to rotate the crank until
the cylinder and the piston are completely in line, and I'll know that because there will be no gap between the piston and the straight edge, or between the straight edge and the cylinder. So I'm going to rotate that now until I have it completely flat. All right, I just did that off camera, and I'm going to come down here and show you that it is completely flat and it's touching the cylinder top, and as well as it is touching the piston top. So we have achieved a completely flat surface between the piston and the cylinder. Now recall, this piston sits a little bit proud of the cylinder, so it's not at top dead center yet. It's just at a place where it is completely leveled across. So now what I'm going to do is I'm going to turn on the dial indicator here, and we're going to see how much the piston travels up above the surface of the cylinder to get my deck height. It's going to be a negative deck height because the piston sits proud of the cylinder at top dead center. But I need to know that number. I need to know how proud it sits at top dead center. So let's turn this on. And I'm going to, while holding that down to make sure it doesn't jiggle, and with my other hand rotating the flywheel here, we're going to get it to be top dead center, and we're going to come back and show you that number. Okay, while holding everything down to make sure nothing moved, I got a negative deck height of 90 thousandths of an inch. And if I were just to sort of move this with my hand here a little bit, I can show you it's going to come down from that number. I move it back, and it's going to go, maybe I can get it to 90.5, I think. No. Tops out at 90. So it is 90 thousandths of an inch above the deck height, or my negative deck height is 90 thousandths of an inch.
Step 4. Calculating the compression ratio.
So I don't exactly have fancy whiteboards like Engineering Explained, but I do have some old dirty cardboard and a Sharpie. So let's talk about the math here of my compression ratio. Currently, as it sits now, my piston sits above my cylinder, above the deck, 90 thousandths of an inch, or a negative 90 thousandths deck height. If I were to get a 60 thousandths head gasket and a 90 thousandths cylinder base shim, which I actually already have, since I was anticipating this happening, I still have to get this guy though. I'll have a deck height of, obviously, 60 thousandths of an inch, or 60 thousandths of an inch below the surface of the combustion chamber there. So if I plug that into my compression ratio calculator, I get some pretty good numbers. So I have a 96 millimeter bore. I have a 78 millimeter stroke. The cc's, which we just measured with wiper fluid, is 60. The combustion chamber is 60 cc's volume. We just sort of talked about my deck height being 60 thousandths of an inch, so you put that in there, and you get a compression ratio of 8.9 to 1. I wanted to hit 9 to 1 for the kind of gas that I'm going to be running and the kind of driving I'm going to be doing, and this is completely fine. 8.9 to 1 is fine. So I'm pretty happy with these numbers, and I think the only missing piece of the puzzle here is to order a 60 thousandths of an inch head gasket.
Step 5. Gapping the rings. My process here consisted of removing the rings with a compressor and seating them into the cylinder, then finding with my feeler gauge what the gap was.
I have a bit of a dilemma here because my rings are supposed to be gapped, top ring at 0.18 inches and bottom ring at 0.20 inches. And this is the bottom ring in there now, right now, and it's hard to show you with one hand here, but 0.20 barely, you have to kind of like push it in, which indicates to me that it's not quite the right size. It goes in, but you really need to kind of push it in, and then it's extremely snug once it's in there. So my question is, do I file down this ring to make the 0.20 feeler gauge, fit sort of more smoothly, or is that sort of action where it sort of takes a little bit of just snaps in at that point? Is that enough? Because that's the only ring that would potentially need to be filed. In fact, the top ring, when I just measured it, came in perfectly at 0.18 to 0.20. So I don't know if I'm going to go ahead and file this. I think I might risk taking too much off, and my tools aren't precise enough to take such a small amount off potentially. And also, I don't even know if it's a problem. And the feeler gauge of 0.020 does fit. It just, you kind of have to give it a little something to get it in there, but it fits. So I'm inclined to say this is a no op, not an issue to deal with, and to clean and clock the rings on the pistons, all four of them, and move on to the next step. So that's what I'm thinking right now.
Step 6. Clocking the rings and installing them into the cylinders. Like most pistons, these came with an instructional diagram to show you how to clock your rings before seating them into the cylinders. What I'm showing here is just a time lapse of one of the cylinders. I clocked and seated all four. So there you have it. I had one cylinder packed and ready to go, and I did the other 3 immediately after. Once my 60,000th head gaskets arrive, we'll be ready to put these on the motor. Next up on Uncle Sal's garage, installing the pistons, cylinders, and heads on the motor.